Hey everyone, welcome back to my channel. In today's video, we are going to learn one of the most important steps in machine learning, data preprocessing. Before training any model, we must clean and prepare our dataset, otherwise, even the best algorithms won't perform well. So, in this video, I'll show you step by step how to handle missing values, how to encode categorical data, how to split datasets into training and testing sets, and how to scale features properly. Let's get started. Step 1. Importing libraries. First, we import the necessary libraries. NumPy is used for numerical operations and working with arrays. Matplotlib is mainly for data visualization, creating graphs and charts. Pandas is super powerful for handling datasets. Think of Pandas as Excel and Python, but with way more features. So, these three libraries are like our base tools for any machine learning project. Step 2. Importing the dataset. Now let's load our dataset. Here we are reading a CSV file. A CSV file is basically a table of data with rows and columns. Next, we separate the features and the target variable. X contains all the independent variables, which means the features we'll use to make predictions. Y contains the dependent variable, the thing we want to predict. For example, if we have a dataset about employees, X may contain age, country, and salary, while Y may contain whether they purchased a product or not. Step 3. Handling missing values. Real-life data is messy. Often, some values are missing. Maybe someone didn't fill their age or salary. If we leave them empty, the model won't work properly. To fix this, we use Scikit-learn's simple imputer. Here's what's happening. Missing values equals NP nan tells the imputer that nan represents missing data. Strategy equals mean means we'll replace missing values with the average of that column. For example, if the salary column has one missing value, it will be replaced by the average salary of all other rows. This makes the dataset complete and ready for analysis. Step 4. Encoding categorical data. Machine learning models work with numbers, not text. If we have a column like country with values like India, France, and Germany, the model won't understand text directly. So, we convert these categories into numbers. First, let's handle the independent variable. Here, one hot encoder creates dummy variables. For example, India 1, 0, 0.
France 0, 1, 0.
Germany 0, 0, 1. This way, we avoid giving any country more weight than another. Next, we encode the dependent variable y. If y has values like yes and no, it converts them to 1 and 0. Simple and efficient. Step 5. Splitting the dataset. Now that our dataset is clean, we split it into training and testing sets. Here's what happens. 80% of the data is used for training the model. 20% is reserved for testing, so we can check how well the model performs. This is super important. Without a test set, we won't know if our model is actually good or just memorizing the training data. Step 6. Feature scaling. This is one of the most critical steps. Imagine you have two features: age, which ranges from 18 to 60, and salary, which ranges from 20,000 to 200,000. If we directly feed this into a model, the algorithm might think salary is way more important just because the numbers are larger. To fix this, we apply feature scaling. We use standardization. Fit transform is applied on the training data. Transform is applied on the test data to use the same scaling as training. Now all values will be scaled so that they have similar ranges, which makes the training process much more accurate. And that's it. We've completed the full data preprocessing pipeline in Python. We covered importing libraries and dataset, handling missing values, encoding categorical data, splitting into training and testing sets, scaling features. These steps are essential before building any machine learning model. In the next videos, we can actually start building ML models using this preprocessed data. If you found this helpful, don't forget to hit like, subscribe, and share with your friends who are learning ML. Thanks for watching, and I'll see you in the next one.